Hello, everyone. Welcome to another episode of the Global Online Meetup. We don't have as many of these lately, and I'm glad that we're getting to do this today with one of the teams out here at Ranja or Susa, or how we call it. As with any live stream that we have on the Rancher YouTube channel or on the Rancher social media platforms, I'd like to request a couple of things by setting the context and by setting some ground rules for engagement. First up, we're here to share knowledge and learn from one another. So it would be extremely helpful if we maintain that environment of learning by being nice to one another during our interactions. The second being, we know that you have questions, and our experts are here to answer them. Please, enter the questions in the chat box provided so that we can relay them to the experts that are there for today's live stream. Um, in the case of today's global online meetup, another thing to be noted is we will have a separate Q&A section towards the end. So we'll not be answering questions as we go. We will be reserving them for the very end of the session, where we will take each and every question that's posted on chat, and we'll be relaying them to the co-panelists for this evening or day, based on wherever you're tuning in from. So I rambled there for quite a bit, and that's on me. But I'm very excited to be bringing on, David and Raul from the Longhorn team to actually talk about the latest release of Longhorn. Version 1.7. It was released last week, I think exactly a week ago. So, David and Raul, welcome to the Global Online Meetup. Really, really thrilled to have you here. Do you all want to go and go ahead and introduce yourself, please?
So, my name is Raul. I'm a technical marketing manager working for SUSE.
Okay, hello everyone. I'm David Cole. Probably some of you met me before in QCOM, so it's great to be here to talk about the latest release of Longhorn. And in this talk, we will generally introduce Longhorn initially, but then dive into the new feature for 1.7. Oh, I forgot to say, I'm the engineering director responsible for Longhorn and Harvester. So good to be here.
And it's great to have you here. I think the last time we did one of these meetups was earlier this year in April, if I'm not wrong. Like not focused on Longhorn potentially, but also like on Harvester and other projects that we spearhead. But it's great to have you both here today. And should we get started with the session then? Do we have a presentation? Should I bring that up? Yeah. All right then. Over to you. Based on whoever's presenting.
Okay, so so we will start this talk with an overview of Longhorn for those who are not familiar with it. Then we will provide a quick summary of the current adoption status of Longhorn, and David will continue with a more detailed explanation on Longhorn capabilities and the latest performance test results. And then we'll do a what's new on the latest 1.7 release, and we'll talk about what is coming on in the roadmap. At the end, we will have, as Divya said, a Q&A session where we will try to answer your questions. So let's start. So for those who are not familiar with Longhorn, it is a highly available software defined block and file storage for Kubernetes. It adds persistent volume support to any certified Kubernetes cluster and is, of course, 100% open source. It was designed with the principles of being lightweight, so it can easily scale and make an efficient use of your hardware resources, um, and being reliable, so that your data is as safe as possible, implementing mechanisms to achieve data redundancy and service high availability to reduce the impact of hardware and software failures, and also offering the possibility to store data backups on any NFS or S3 compatible external storage device. And the other principle is being easy to use. So it has an intuitive web UI and simple ways to manage and store your data. For example, any file system supporting sparse files can be added to your Longhorn cluster to where you can store data. And being hardware and infrastructure agnostic makes it easy to run it nearly anywhere. Longhorn is also Kubernetes native. In fact, it's a CNCF incubating project, and this means that you can interact with it as you do with any other Kubernetes native application. It also follows the principles of being easy and simple to automate and manage. So this is a diagram of the backend architecture. So Longhorn is based on microservices where there is one engine or controller per Kubernetes volume and one replica agent for each replica that handles the I/O to the underlying storage on each cluster. And this design makes it more resilient to failure by limiting the impact to only those volumes affected and not every volume in the cluster. It also makes it easier to automate upgrades, for example, and do non-disruptive canary upgrades with automated rollback in case of failure. But next slide. So Longhorn adoption. So here I'm gonna give you a glimpse of what is the current usage status and how Longhorn adoption is evolving. Longhorn is currently being used in more than 20,000 clusters around the world, with more than 131,000 cluster nodes running it. There are examples of clusters with more than 400 nodes using it. That is not the average home lab, so it's used professionally as well. Since Longhorn can run multiple versions of Kubernetes, we see the most common versions where it runs are those between 1.24 and 1.31. It is also used on different infrastructure solutions such as Edge, data platform, virtual machines, and so on. And the good news is that despite not being a new project, it is still growing steadily. So since last year, we saw a 45% increase in the number of active nodes that run Longhorn components and a whopping 455% increase in the number of active clusters using it. If you wonder where do these numbers come from, most of them come from can be found inside metrics.longhorn.io. You have the URL on the top. And now I'm gonna pass it to David, that is gonna talk about Longhorn capabilities and performance. All yours.
Okay, great. Let me share my screen. Let me share my screen. Give me a second. Okay, can you see my screen?
Yes.
I think yes. Okay, good.
Yeah,
Thanks
yeah.
for
Sorry.
introduction for Longhorn in general overview and current adoption status. And what I want to talk about before diving into Longhorn 1.7 features, highlighted features, I want the people join here to understand better how Longhorn can provide, including capability and the current performance status. Okay, so if we talk about loan capability, I always use different angles to let the people understand how loan can support. And the primary um, ideas in mind when we're doing the loan development, we want loan as a general solution can be for different kind of deployment places. So I call it deployment agility. So one loan can run anywhere, including different type of distro, Kubernetes distro, operating system architecture, and have a different way for installation and upgrade, and also various infrastructure support. So for Kubernetes distro, any certified Kubernetes such as RK2 and K3S, we can support it. But beyond that, even vanilla Kubernetes distro alone also can run on it without any issues, and or we can say run it perfectly. And for architecture, Long already support AMD64 and ARM64 for a long while. And because we know different usage will be depends on different architectures. So this is what we are targeting for. And for installation and upgrade, usually most of the project will provide a unified installation way, like Hamcha. For sure, Longhorn support that, but we have a, seamless integration into Rancher as well. So in the Rancher application marketplace, you can install the latest Longhorn stable version from there as well. Okay. For uh, besides Hamcha installation, Venture Application Marketplace, we also support GitOps because automation is always the first class that we want to make our infra deployment more productive, efficient. So for Longhorn, we already have verified Longhorn can be managed by Fleet, SUSE Fleet, Argo CD, and Flux. We have a dedicated QA testing pipeline for this GitHub solution to make sure for each Longhorn release can be managed well by this solution. And also, if talk about upgrade, you can use a Ham Rancher GitOps to do that. But most important thing I want to mention, Longhorn is a Kubernetes upgrade awareness. What does that mean? It means Longhorn have a specific no drain policy with the different options to that user can support. For example, when you are rolling on the node is going to be drained, only have a less healthy replica layer, there's a mode for block if less healthy replica layer. So you will not allow to drain the node until the replica can be rebuilt on another node. So more than one healthy replica. But not just one options, we provide different options and that you decide depends on your company's infra compliance to follow your policy to see how you want to upgrade your Kubernetes together with a storage solution. Okay, so this is installation and upgrade. How about infra? uh, we want to target on-prem, private or public cloud, and edge and resource constraint. For example, on-prem, you can install Longhorn on-prem bare metal server for sure if a Kubernetes run on it. But more than that, we even integrate some Kubernetes solution like Harvester, hyperconverged infrastructure solution. The underlying first-class storage solution will be is Longhorn, so we can run with it naturally, work without any issues. And for sure, the underlying support for underlying component support Harvester is Kuber. So they mean Longhorn can be run with Kuber without issue as well. So this is just a few examples for on-prem setup. But for private cloud and public cloud, for sure, Longhorn can support that because it just depends on the certified Kubernetes. However, for public cloud, these are little things, something we need to do first. Like for example, the famous the public cloud distro, including AKS, EKS, GKE, and we want to make it work well with Longhorn. So for QA, from QA perspective, we have a dedicated QA pipeline to test the AKS, EKS, GKs for each release, the same as the GitHub apps. But beyond that, public cloud Kubernetes also can provide the more scalable features like cluster auto scale and no pool upgrade. And this kind of primary item, Long also support that. So simply say, Long can support the public cloud, especially with certified. But if not certified, you still can go into try and do feedback to us if you have any issue or any feedback. And let's talk about last one, age. And age matters because different kind of scenario, you want to have a small Kubernetes cluster or large Kubernetes cluster at the edge, and want to long haul with the with that user have an impression. You don't need to use a too high or too much resource for long haul, and because long haul can be adaptive to a different environment. So for age, C Michael, we can run C Michael well and with the latest version, and also the SUSE Edge solution integrate Longhorn as a storage component for its the product stack. And sorry, okay, so the Edge will mostly focus on the low resource footprint. Okay, next, we talk about the deployment agilities. How about core features? Simply say we around the normal capability, the core function around the CSI. So for the PM, PVC, or PV, all the functionality, most of functionality we already support, like a broad volume, file system volume, rewrite only or rewrite many. And even beyond that, we want Longhorn can support VM workload as well. So VM volume can be a backend modeling for the VM. So we call it back image broad volume. And for CSI, there are some interface and functionality already supported by the CSI interface. And Longhorn also does support most of them, like a volume provision, attachment, snapshot clone, expansion, etc. And the volume capability Longhorn itself provides, we provide a same provision and snapshot for the copy on write and volume trim, live volume upgrade. If when you upgrade the Longhorn, your volume will be not be interrupted. And also live migration, you can migrate your volume to a different node at runtime without any volume interruption because everything's still running. And next one is IO performance. This is very important for us. And right now we have a V1 data engine based on iSCSI stack. And so we created different kind of things to improve that, like a data locality, local volume, street volume, to make we can provide a better performance in the current architecture. However, the current architecture actually have some challenge to re- to make the performance better. So we are working on the V2 data engine based on SPDK, stuff from the Longhorn V1 1.5, and we continue on that. And also in 1.7, we have a new features we want to share later. Okay, and talk about storage topology. You want to decide how to distribute your volume replicas. Longhorn have a configuration for that. You can do the configuration like a no select and a tent. Also, no zone, no disk replica scheduling anti-affinity to design. You want to let the replica can be on the same node or different nodes, different zone, or same node or different node, or even distribute across the disk. And also we have a special concept is a storage tag. So you can categorize your disk. So like a low speed disk for any for some type of workload to use, but faster disk can use the for the data intensive workload to use. So this is that you have a better solution to arrange your replica how to distribute. Okay. So data protections, we have a data replication, data encryption in transit and the arrest, also B-roll protection. We try to use the snapshot checksum to make sure the snapshot will not be in data will not be inconsistent. Okay, if something wrong, break the data integrity, we will fix the snapshot to drop out the bad snapshot to rebuild the snapshot from the healthy replica. So this is not just prevention, we also have a collection for big road protection. And about the data service, we not just provide the volume functions, we also have in cluster snapshot and revert. And also we have a built-in out of cluster backup and restore. Of course, you can use the other solution to do a backup restore, like a Castan, Viero, but we have a built-in solution, so it's a naturally uh, aligned with the our Longhorn volume design. And of course, disaster recovery. You can have a disaster recovery plan to prepare standby cluster to incrementally back up your volume to another class and activate the volume until you need it. Okay. The last one is data reductions. We know snapshot based volume do cause some extra space usage. So we have a different kind of thing to save the space efficiency, like the number of sensor you can define, and the recurrent job you can periodically connect your sensor, and merge your sensor, and also backup compression. So not just in cluster data reduction, also care about the external cluster backup reduction. So uh, this is I want to share with you the core function of the Longhorn can provide. But beyond that, Longhorn also provides other function. If you're interested, you can later you can check the Longhorn documentation. So the few pillars I want to mention: resilience, availability, consistency, reliability, and fault tolerance. There's always the key factor when we develop each Longhorn release. Okay, so the first one is stuff on the Longhorn 1.5 until today, 1.7. We still continue adding the V2 functionalities. So before diving into the 1.7 features, I want to share with you the current performance. If you compare with the V1 and the new V2s, how it look like. And the test bed we are running on the EQNIX model, and the baseline to test the raw disk performance, we use a local path provisioner, and the spec is like that. The CPU is the 8 cores, 60 threads, and the RAM is 64 gigabyte memory. Kubernetes Reno standard cluster, and the operation system and kernel in 554. And this is why I want to showcase that we have a good setup and good network speeds between the nodes, and also is the high performance SSD. Let's look into the IOPS. Blue bar is for the local pace provisioner. So you can think about this performance matrix can be a baseline. And the orange one is for V1 engine, V1 data engine. The red one is for the V2 data engine. We use the small data block to understand how the capability we can achieve for IOPS. So if you look into the one every car volumes for the V1 or V2, you will see the ray bar, the ray bar, the light ray bar is very close to blue bar. So it's the very close to baseline performance. But if compare with the V1, you will see the V2 gain a lot of performance uh, from the V1. And if you look into if we have more than one replica, maybe three replica on the different nodes, you will see the tremendous difference if you compare the performance between the V1 and V2. This is quite impressive. We can see how V2 can bring the better IOPS, and especially you have a high data intensive application, and this kind of improve definitely will improve your workload performance and productivity as well. And for the throughput, and the same, you will see the red bar is the V2. It's still can achieve the higher performance, higher throughput than baseline and V1. For sure, it is better for baseline because it will be aggregate the throughput from the downstream replicas. So if you have more than one, you'll be aggregate. But in general, you will see a performance is pretty good for the reports. Okay. So for the latency, okay, we try to understand how the small data block can be achieved the low latency. So you will see the V1, the yellow one, has a very high latency if you compare with V2. And V2, it depends on how many replica you have, but the performance is quite better than V1. So this is why we continue to invest in V2 development from V2 1.5 and 1.6, and right now 1.7. Okay, It's a title about the Longhorn 1.7, so let's dive into. So I will not go through all the functions here. So primarily, sorry for that. So mainly focus on the highlighted features. For each Longhorn release, we always emphasize some highlighted features to let user capture, to grab the points to understand what's the important feature we come into the new release. So 1.7, the first thing I want to highlight is the V2 data engine feature. We try to add the more features V1 we have right now to add into the V2. So I call it feature parity. So in 1.7, we have online replica rebuilding. So in previous version 1.6, we only have an offline replica rebuilding. So the replica rebuilding only happens in 1.6 when you detach the volume and reattach again. And before reattach again, we will do the offline rebuilding to make sure the replica's ready and to allow you to attach your volume. Okay. But in 1.7, right now, your volume will be not interrupted. You will continue working with your workload. And at runtime, if you have a replicas encounter error, Longhorn will be automatically rebuild replica for you without any IO interruption. And the second one is a broad type disk supports. Because SPDK have a different disk drivers to support like AIO, NVMe, or VIO, and have a different capacity for this driver. And initially, before the 1.7, we only have AIO for only all type of a disk. But in 1.7, we want to have adaptive way to have AIO in general, NVMe for if you have NVMe broad disk, and for VIO broad disk BDF drivers, if you run the Longhorn in the VM and your VN disk is a support, it can be supported by the VIO BDF. Okay, so in the different scenario, we can manage the raw disk better to serve the V2 data engine with a better performance. So this is broad type disk. And file system tree, we already have a tree support for the V1 data engine. And initially, for Longhorn, when we start working on the 1.7, SPDK AIO does not support file system tree. So that means we only can leverage NVMe and VIO, but it will be a challenge for the drivers. We need to have a general drivers for a general raw disk. But right now, Longhorn 1.7, we couple with the latest SPDK release. And the latest SPDK release, the AIO BDF driver, already support file system trim. So they mean we can support file system trim for all type of BDF driver we support in 1.7. So you will be reclaim your own use the space effectively to free your space usage from your disk. So this is the three primary item. But beyond that, we also have this one. This is very important. V2 volume support for data plane life upgrade because we need to prepare earlier. We want to make the V2 data engine GA in the following release. So we need to start plan. How about the Longhorn do a live upgrade? When you upgrade the Longhorn version, how does the SVK version also upgrade? How does it work? So we have a two phase. In the 1.7, we are doing the data plane pace upgrade. So this is some diagram here. This is not a whole diagram. I just captured the three of them to demonstrate how it works. But the the second part phase, there are two parts. The second part phase is control plane pace, okay, control plane parts, and we want to make it happen in the next feature release. Minor release is the 1.8. So when we have a 1.8, they mean the volume life upgrade will be completely supported. But in 1.7, how we make it happen? So in each volume, we will have a DN device in front of them. So when our data plane component is an instance manager, in the instance manager, we run SPDK TGT process. Is the main daemons to manage all the SPK volume inside. When you're doing the database upgrade, we will suspend the front end, the DM device to suspend and do the target switch. And to that, the new instant major running up with the new SPK TDD process. And then bring up the new MBNE PDF inside the new instance major pods and do the target switch. So you will see the diagram here. There's a NVMe V0 and the NVMe V1. And initially, we only have a NVMe V1 and NVMe 0, and we do a switch to NVMe V1 temporary. And later, if we have a new instance running, then we can drop down the NVMe 1 and bring up the NVMe 0 back and resume the front end DM device. This is the primary fundamental concept. We do a target switch to make sure there's no I/O interruption. And again, this is the first part. So please expect the complete live volume upgrades in the 1.8. Okay, we talked about the V2, and there are also other very exciting features I want to talk about. And high availability pods, there are two items. One, we add a high availability for the back image to mitigate some risk if we have an image failure. If you don't know about the back image, the purpose of a back image to support the volume for the VM, virtualization VM, virtual machine. So the virtual machine, the root disk can based on the Longhorn volume, and Longhorn volume can be based, the empty Longhorn volume can based on the one backing image. And before the 1.7, the back image, there's no HA until you have a more volume use the same back image. The back image will be replicated to other nodes, other disks to make the ability happens. But it will only happen when you need it. In 1.7, something different. We introduced the new attribute to backing image spec. We call it minimal numbers of copies. So you can define how many copy you want and rely on Longhorn replica scheduling mechanism to figure out the high capability of disk. So when you do the back image creation by the three way we provide right now is upload the image, download the image, and clone the image. And we will go through the Longhorn control plane. You will determine, okay, this back image, how many numbers of copy we need. And he will distribute to the image to create the high available capacity of disk and node to make sure we can balance to place the back image in the different node, different disk. So it will be a case if you lose the one, if you haven't created any volume based on back image, and you accidentally lose the one disk and the back image on the disk, you will miss that. Then you need to create another new back image. But in the current new mechanism, we will have more than one image in a different disk or even different nodes. So if you have a disk lost or no disk node lost, you still have a chance to have a back image available for your volume. Okay, so this first part, back image highly HA. The second part is the failover and recovery for rewrite many. And we also can call it rewrite many volume HA. Before 1.7, we don't have the concrete way for rewrite many HA. And there's always single point of failure. We only have one share manager for the rewrite many volume. We depend on Kubernetes mechanism to detect the no failure, to recover the share manager, to make sure the user, the workload can be continue working on the rewrite many volume. And you will take a longer time to come back. And in 1.7, the thing is different. We introduced the list mechanism based on Kubernetes built-in resource list, and we have a share manager pod, and Longhorn control plane will watch the share manager pod and have it has a corresponding lease. If the share manager part life cycle is out of life cycle, the lease is out of date, is not refreshed anymore. Longhorn control plane will immediately tell the control to delete the share manager parts and to make the share manager part recreate. So this made the rewrite many volume HH happens. So in the past, we probably need to tag the if you are running a good stable Kubernetes cluster, you probably take the 90 seconds to make the share image part recover. But right now, you probably take the 50 seconds to 30 seconds to make the share image part come back. So that means you will minimize the downtime so that your workload can be continue the service uh, in a short time to until the share major pop back. But this is a tremendous important improvement for rewrite many because we know this is a primary challenge for user when they use a rewrite many volumes. Data protections. Okay, we support a periodical uh, backup before the 1.6 is the delta incrementals. So if you look at before the chain, you will see when you do a backup one, backup two, or backup three, you always delta. If you already have a data proc on the backup store, Long will not send the data again. It just reference it. But this creates another problems. If you somehow your environment is not stable, and the or even your backup target backup store have some problem about the data persistent on it, and there are some broken data block inside the remote backup target, and Long is not aware of that. So Long will continue doing the incremental backup. That's it. But actually, your data already corrupted and inconsistency. So we provide the on-demand full backup, and you can do the on-demand, or even you can leverage a recurring backup to have a few times to do the full backup again, and or you still want to use the delta. It depends on your design because you can create a several recurring job. One recurring job do a full backup, the other recurring job doing the delta backup, and set up the good cadency so you will make sure your data will be well protected. And the next one is the backing image encryption. Before 1.7, we support the volume encryption, but if your volume is based on backing image, there's no support for that. But in 1.7, we support that. We even support that you can uncrypt the back image, or you can decrypt the encrypt the back image, or you can create an encrypt the volume based on encrypt the back image with the same critical cryptographic key. And this is very important because, like I say, some on premium solution like a SUSE Harvester or even Cuber, some users use a Cuber together with a Longhorn and they want to do a volume encryption for their boot disk and also their data disk data volume. And in the past, they only can do the encryption for the data volume, but right now they can do the encryption for their boot volume as well. So this is very important to make the encryption capacity can apply a different type of volumes. Okay, efficient replica scheduling and reviews. We have a two outstanding improvement here, and the one is the auto rebalancing. We already have a replica auto rebalancing across the node, across the zone, but right now we do across the disk if there are some disk pressure happens. And the second one, we improve the performance, have a faster replica rebuilding to rely on the local replica sync instead of a replica sync across the TCP over the TCP. So there are there are once a new setting here, replica auto balance disk pressure threshold. You can define for that. And if your disk have some pressures and replica cannot create on that, or even there are some problems to review on the disk, you will be due on another disk to make sure you can better leverage your disk capacity from the same nodes, not just rebuild everything on the other nodes. No, right now we can support that. Or even your disk is out of space, we will auto balancing, move your replica from one disk to another disk in the same nodes. So this is something we cannot do before, but right now 1.7 we can support it. And for the replica rebuilding, if it happened on in the same nodes, we can, but you have a multiple disk, we can do a local copy between the between the disk on the same node. So this is outstanding, very important for volume rebuilding, especially you have a very large size of volume. Okay, so the next is platform agnostic. We support this what I said before, deployment agilities. So we support the uh, C micros, immutable operating systems. We also support Talos, Ninas, and right now, this version we support COS. It's a container operating system by Google. And there are some limitations for that. This is very traditional for the immutable operating system. No package managers, no, not for the non-container solution applications. You cannot install the third-party kernel module or driver because it's an immutable operating system. So in this version, we introduced the COS no agent installation. So to install, it's a daemon say, to install necessary package at runtime. So you can run the Longhorn on this new immutable operating system. Storage network. We support storage network before for rewrite only, but right now we expand the capacity to the rewrite only. If you see the diagram below the left side, rewrite only and share manager part, this is current support. The Longhorn database, Longhorn volume database already support that, and we based on the storage network by Martyrs, yes. And for rewrite manually, because we want the run the NFS server inside share manager, so in before the 1.7, it still rely on cluster network. But right now, if you enable the storage network, you will go through the storage network. So that means we cover the rewrite only and rewrite only. Then that you do the network segregation for your control base and database. Last one, long CLI. And people sometimes in the past always ask, can we have a dedicated CLI for Longhorn? I think for sure yes, but we want to do something different because Longhorn is based on customer resource. And for customer resource, you already can be use the Kubernetes CLI kubectl to manage all the Longhorn resource. So we don't want to create the similar functionality in our CLI. So Longhorn CLI is focusing on to simplify your operation, to simplify your troubleshooting, to make you can be better manage your Longhorn on day two. So there are three primary cases here. Installation or verify some precondition, pre-flight requirements you need for your Longhorn. In the past, we have a share script and you can run it. You will bring up the daemon set, but right now you can just use the CLI to do that. And you can do some one-time Longhorn operation like a trim, export the volume, trim the volume, and also get the information about the volume or replicas. This you can do in the 1.7 CLI. And we want to do more. So in 1.8 and 1.8, we also want to do more troubleshooting capability to CLI. So if you are using Longhorn and you have any idea about want to troubleshoot or make your Longhorn operation better on day two, please let us know or create a ticket or request for us. Okay. And I just put an example here. The right-hand side, you will see install the preflight. And you can, for the V1 or even for V2 enable SPK, it will install necessary package for you for V1 and V2. Okay, so this is CLI. Yeah, so the last part before Q&A is a roadmap. The left side is the 170. We already achieved that. And the highlighted feature, I try to spend spend this time to introduce that and hope you can understand. And we will plan the following section, following meetup, probably at upstream CNCF, so we can dive into the more demo layer if we have more time. But I want to talk about 1.0, and the something different we want to do start from 1.0. The first one is the new 4 months release cadency. So start from 1.0, we will release uh, next January 2025. And after 4 months, we will release the one night. So this will be our consistent release cadency and release time window uh, in the future. So the purpose is that the user know better when they can expect the Longhorn new version will be come out with a new feature. Okay, this is the first one. The second one is the feature 1.8 we want to come out. The primary part is the V2. We want to add the most feature parity features for the V1 to V2, like a volume up, life upgrade complete with the control plane parts, snapshot checksum, delta replica rebuilding, online rebuilding improvement, auto salvage from the failed replica, from auto salvage from the failed volume, DR volume, volume life upgrade, volume life migration, back image volume encryption expansion, or also dynamic scheduler. Because right now you need to have a dedicated CPU count for V2. But right now we are investigate to use the less one CPU count for one CPU core for SPK. So can that the V2 can run on the edge as well. So this first one for V2 and multiple backup store to support a multiple backup store. To that you can pick up your volume to a different backup store. And also the other important part is the V1 data engine performance improvement. At the same time, while we are working on V2, we also care about V1 performance. So the V1 right now is based on iSCSI. In one ad, we try to experience the uBlock front end to make sure we can have a new performance scan for a uh, new tech stack. So you are based on uBlock. And the last one is resource constraint strategy. So many things to do, and I hope I share this kind of information to let you understand what we already have for 1.7 and what we plan to do for 1.8. Okay, so yeah, that's it.
Right, and that was a very insightful, sort of presentation by both you, Raul, and David. We have a single question as of now, but if there are any other questions that folks have, please feel free to chime in with them in the chat box. The first one is from Twitter, by Alexandru. I hope I'm getting your name right. Um, Not sure if this was mentioned. What is the minimal K8 version that's supported by Longhorn version 1.7? That's the first question that he has. And the second question is, can we upgrade existing volumes from 1.3.x directly?
Yeah, for the first question, Longhorn can support you if you still have Kubernetes 1.21. So it's very old version because we based on CSI interface. So the CSI interface is very compatible. So we can stay on the old version, but we still encourage you use the new Kubernetes version because Kubernetes over time they're still improving their path scheduling and some building capabilities, functionalities, and long all the functionality based on the Kubernetes. So we still encourage user to use the newer versions. However, the minimum version is 121. And for the second question, upgrade is in volume from 13x for sure, but you need to upgrade Longhorn first, follow the database. So Longhorn support 13x to upgrade to 14x, then 15x, then 16x, and 17x. So you need to do this database because each migration, each upgrade, we have a dedicated upgrade path for that. And so you need to be pay attention to it. And but for 13x, we also recently, after release 170, we have a one issue about 13x volumes, about the name of the engine. And we are working on that. So by this week, we will release a 171 as a patch release to make sure it work. So please expect for it because this will be a new release. Yeah,
And
can I
I'm on
hear
mute.
you?
Yeah, yeah, no, no, no. I was on mute. I am really sorry. I tend to keep myself on mute when others are, speaking, so that there's no background noise coming in. There's another question that's come in from Alexandra. Hello, what about ISO block divisions between machines for creating large disks, cross storage VMs?
Yeah, people always ask. Okay, yeah, let me answer this one. We have an idea and feature about the sharding. And originally we planned to do based on the V1 data engine, but V1 data engine have some performance challenge. So we pivot it. We want to do it for based on the B2 data engine, based on SPDK. So he will, for my for my current for my for my current understanding, originally we planned for 1.8, but right now probably moved to 1.9. But please follow up the roadmap. We have a roadmap patch on the long reports. We have a wiki page for that. So please follow up. But we definitely this is outstanding items we want to do that after we catch up the V1 capacity for V2.
All right. I do not think there are any other questions for now. Um, and I think that was the end of the questions that came in. If there are, we can give it a couple of more minutes before we close out for the day. But I really want to thank both of you because y'all came on today and actually shared knowledge about the latest release. This will be available for later viewing, but thank you so much for taking our time today and for uh, uh, answering all those questions from our viewers. Since there are no further questions, I'll let you get back to your respective workloads. And for David, I think it's bedtime, so I'll let you get back.
And by the way, because we have upcoming like a QCon, right, in North America,
Yeah,
so long will be there always. So
yeah.
if you have any, yeah, you have a question about a SUSE product, harvester, venture, new vectors, or even Longhorn, please come to visit our booth because it will happen soon.
Yeah, and also just so that people on the live stream are aware, on Rancher Academy, that is https www.rancher.academy, we have a Longhorn basics course that
Yeah,
focuses on how you can get started with Longhorn in case you're really new to the ecosystem. It's a very good course that's designed by one of the experts in SUSE on how to start from the very scratch,
yeah,
including all the machine requirements, everything. So if you're new to the ecosystem, please do check it out and let us know your feedback.
sounds good.
Yep. So thank you once again, David and Raul. I will, let everyone get back to their respective lives, and we'll see you on another live stream soon. Thank you, and have a great day slash eve. Bye.
Bye
Thank you.
bye.
Bye.